show you what grade you're going to teach us. It said something about it was an error.
Blackboard was down, wasn't it?
Maybe it was. Before we leave the classroom today, I want you to try it on the Chromebook, and if we've got a problem, I'll submit a technology issue for you, okay? All right, so what we do is we look at this one and we look at this one. What do you multiply x by to get 2x squared? 2x. So a 2x goes here. So then we have to multiply the 2x times the x plus 6. And if you need to, folks, just show it over to the side. 2x times x plus 6 is 2x plus 12. So that's what goes here. 2x plus 12. 2x squared plus 12x. I left the x out when I multiplied. Sorry. All right, so when we subtract, and you may want to do this in a different color, so you always remember, when we subtract, it changes all of the signs. So then we have a negative 5x minus 30, because we always bring down. And then here we say, what do you multiply x by to get negative 5x? And what is that? Negative 5. So now we have to do negative 5 times x plus 6, which is negative 5x plus 30. Nope, minus 30. Okay, so when we go through and subtract, it changes both of these to positive, which one means there's no remainder. All right, so this is my answer. And when there's no remainder, what does it tell us about our divisor? It is a factor. Very good. When there's no remainder, it tells us that our divisor is a factor of the dividend. All right, number 2. The only way we can do number 2 is long division. So we're going to put all our stuff out here. And then the dividend goes under here. And even though it looks like a long problem, it's not really. Okay, so what do you multiply x squared by to get x cubed? Just an x. So if you look at it and you line it up the way we talked about lining it up yesterday, you can tell we're almost done. We're almost to the end of this division bar. So x times all this stuff makes everything just go up by 1 degree. So this was x, now it's x squared. This was 1, now it's 1x. Everything went up by 1.
Dividing into the equation, what first number is a negative?
Then we just have a negative right here.
No.
Okay, so when we change signs, that's going to give us a 3x squared plus 3x, and then we have to bring down the plus 3. So what do you multiply the x squared by to get a 3x squared? A positive 3. So 3 times this is 3x squared. 3 times the middle one is 3x. 3 times 1 is 3. All right, so we subtract, which changes all of our signs. And we're left with 0. No remainder. So this is my answer, x plus 3. Okay, so that's long division. Now, number 2, you'd have to do long division on. Number 1, you wouldn't. Number 1 is like these down here. So, we're going to remind ourselves about synthetic division now. Okay? So, to start synthetic division, we look at our factor, and we put the opposite right here, -4. Now, the reason we can do synthetic is because this divisor is just a binomial. It's a first power, and it has a leading coefficient of 1. That's when we use synthetic. So this is a great problem for synthetic. Then we take our coefficients and our constant. The coefficient of x squared is 1. The coefficient of x is 7. And the constant is 12. We bring down the first one. Then we multiply -4 times that one, and then we add. 7 plus -4 is 3. Then we multiply. 4 times -3 is -12. And then we add 0. Now, this last one is always the remainder. So this one has no remainder. And then every time we work our way backwards, the first one doesn't have an x. The next one gets an x. If we add another one, it would get an x squared. So this is our answer right here. X plus 3. There was no remainder. So now we're supposed to determine if the divisor is a factor. Well, if it's no remainder, is this a factor?
Yes.
Yes. Yes, this one is. Okay, we're going to do number 4 together.
If it's not a factor, would your...
You would have a remainder if it's not a factor. Okay, so what goes on the table? 5. And then we pull off our coefficients and our constant. 2, -11, 8, and -15. Okay, we bring down the first one. Every time you bring down the first one, say 2. And then you multiply. 5 times 2 is 10. And then we add. -1. And then we multiply. And then we add. And then we multiply. And then we add. Okay, what does this tell us? No remainder, so this is yes, it is a factor. And now let's write our answer. So this is our plain old number. This one gets an x, and this one would get a x squared. So I don't have to write plus a negative. I could just write my answer 2x squared minus, I don't even have to write 1x. I can just say minus x plus 3. And that's my answer. And yes, it is a factor because my remainder is 0. Yes, sir.
I was confused about the other parts when we get the numbers down.
Down here?
No.
Okay.
Up top, like ones below the that those
These right here?
numbers.
Okay.
Yes.
Let's go back over that then. So what we do to get these numbers, I'm going to erase this extra part right here. We'll just kind of start back over and talk about where those numbers come from. So every time, this is just our rule, we bring down that first one. And this first one helps us get this one. So you take the number that's on the table, 5, and it gets x multiplied times this. So 5 times 2 is 10. And that's where this number comes from. Doing 5 times 2. Okay? Negative 11 plus 10 is negative 1. So now we add them. And then what you do it again. But this time we do 5 times the negative 1. What is 5 times negative 1? Negative 5. And then we add them. 8 plus negative 5 is 3. To get the next number, now we do it times this one. 5 times 3 is 15. And then we add them, and we get the 0. So that's where these numbers come from. Does that help any?
Yeah.
Okay. All right. So now, when you get to here is where you have to go back, work your way back and put the variables in. This number is always your constant, your plain old number. This one gets an x, and this one gets an x squared. We work our way back and go back up with our degree. So it's 2x squared minus x plus 3. And yes, it is a factor because the remainder is 0. All right. We're going to save some of the other ones and we're going to come down here to number 11 because I did not get to these yesterday. I'm going to have to snip this so it'll go a little higher. Okay, so just like when we take the number and do the opposite and put it on the table, you can also find if a root, this is what we did to find if a factor is if an expression is a factor of the polynomial. But to find out if we have a root of the polynomial, there's a quicker way to do it. And the quick way to do it, here, if we want to figure out if x equals 1 is a root, what we do is we take the function and we just plug in 1. Okay? When we plug in 1, this time I get 1 minus 4 is negative 3. So this one is not a root. And the reason it's not a root, we know it's a root when it equals 0, just like the remainder being 0. This is called the remainder theorem. It's kind of a shortcut to finding the remainder. So if you take this root and plug it in, if you get out 0, then it is a root. If you get out anything else, it is not a root. Okay? Now, I want you to try p of negative 2. Okay, so when we plug in negative 2, we get out 4 plus a negative 6 plus 1. Well, this is negative 1. So is this a root? No, not a root. Okay, let's go back to number 11. We're going to revisit number 11, and I want to show you what happens when it is a root. So this was number 11. Let's do P of 2. When we plug in a 2, 2 squared minus 4. What is 4 minus 4? 0. So P of 2, 2 is a root. Because we got out 0. Okay, so that was the part of yesterday's lesson I didn't get to here. Does that make sense? All right. Okay, so now we'll go to the new stuff. And some of you have already been to math, so you know what's going on here. And some of you haven't been to math, so this just looks like a beehive. Okay, so this is set up for us to discover Pascal's triangle. Now, Pascal's triangle is part of the binomial theorem, but don't go home and Google the binomial theorem, because we really only do Pascal. The binomial theorem is actually super cool. It takes combinations. Do you remember combinations and permutations from last year?
Yes.
It uses combinations to help us expand binomials. But we're not going to make you do that. We're really just using Pascal's more than the binomial theorem. And we're using it as a shortcut. It's really a shortcut way to expand binomials. So, what happens here is Pascal's is basically where we take x plus y and we raise it to powers. This first line is to the 0 power. Well, anything to the 0 power is just 1. So this one has a single 1. And then the next row represents where we do x plus y to the first power. And we look at the understood coefficients. Understood to be 1, understood to be 1. So that's where the 1 and the 1 come from. Now the next row is where we take x plus y and we square it. Okay? Now when we square x plus y, our answer looks like this. It is 1x plus 2xy plus 1y squared. So it's 1, 2, 1 when we look at our coefficients. Now the next row would be if we were to cube it. What would those coefficients look like? Well, it would be 1, 3, 3, 1. And then the next one is 1, 4, 6, 4, 1. Okay? So I want you to see if you can see a pattern in here, and some of you I think already can because you were answering me, and see if you try to fill in that next line without my help. Okay. So I want you to look at this row compared to the row above. See if you see a relationship. Every time. What's going on?
I didn't get that one for you.
No, it's, oh, here it is. I had set them over here. Here's my extra. I am pretty sure I ran off 21 copies. I have 21 students. Destiny, yesterday I realized you're not on my math number list. Somehow, when they moved you into my class, I didn't add you to my roster. So I was entering your fabulous test grade yesterday in my grade book, and I was like, he's not in my grade book. But you were in my grade book. And so you guys got reassigned numbers yesterday. I'll post those later. All right, so the next one is 1, 5, 10, 10, 5, 1. And let's talk about y. number below, you can do the sum of the two above. 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 And that is how you build Pascal's triangle. Now hopefully your teacher will show you about all the really cool things about Pascal's today. I am a total math nerd, so Pascal's is just, you know what, I gotta show you.
It's obsessive?
Huh?
Obsessive?
I'm obsessive about math, yes. I have math problems. Alright, where are my favorites? I don't know how to use this. I'm a Chrome girl. Does it do it out? There we go. Alright, so here's a website I really like. It's called Math is Fun. But it has lots of cool things about Pascal's, and if I teach you, you'll see this again today, or this is already the second time you've seen it. So the first thing it talks about is how to build Pascal's, and we just talked about that too. But there's lots of cool things hidden within Pascal's triangle. You'll notice that down the diagonals, either this diagonal or this diagonal, you have all ones. But then right beside it, you have your counting numbers. Do you see this way counting numbers and this way counting numbers? And then right beside that, you have what's called triangular numbers. So 1 is a triangular number, 3 is a triangular number. The reason it's called triangular is because three dots form a triangle. The next triangle number is 6 because 6 dots form a triangle. The next triangular number is 10. Okay, so if you ever hear the term triangular numbers, that's what it's talking about. So those are our triangular numbers. The next one is our tetrahedral numbers. All right. Pascal's triangle is symmetrical. The left and right side are identical. Now here's something cool. If we did the rows and add up the sums, look at them. 1, 2, 4, 8, 16, 32, 64, 128. All of those are powers of 2. Another cool thing, we can also think of it as 11 raised to a power. So 11 to the 0 is 1. 11 to the first is 1, 1. 11 squared is 1, 2, 1. 11 to the third is 1, 3, 3, 1. Yes, it is. All right. The other thing that's hidden inside Pascal's is, see this highlighted number here, 4. 4 squared is 16, right? So 4 squared is 10 plus 6. I'm going to do this so I can look at another one. 4 squared is 10 plus 6. 3 squared is 6 plus 3. 5 squared is 10 plus 15. Your perfect squares are hidden inside Pascal's. All right. Another thing about Pascal's is the Fibonacci sequence. What do you guys know about the Fibonacci sequence? You don't know Fibonacci?
No, we haven't heard of it.
I've
Okay.
never heard of this at all.
You haven't heard of Fibonacci? All right, the Fibonacci sequence is where the next number is the sum of the two previous. So the Fibonacci sequence is inside Pascal's. And then this one, this is cool. If you were to highlight the evens versus the odds differently, it ends up making this pattern of really cool triangles that repeats forever. So depends on how many rows you have. And it gets cooler and cooler, and we can kind of use the same thing with just shapes and form the same thing. Okay. Oh, this is the part that leads us into the binomial theorem. All of these coefficients are actually, they come from combinations. The combinations of, we did N and R. N choose R. They used K here. But when we did combinations, we said N and R because our calculator uses N and R. Do you remember that?
No.
NCR and NPR? You don't remember that? Okay. Well, that's what those coefficients are. The coefficients are also combinations. So there's the first 15 lines of Pascal's. Now,
15 lines.
I would never do 15 lines. I might use Pascal's up to 5. And then after that, I'd definitely be using combinations. All right, so Pascal's has lots of cool application, but we're kind of narrowing it down to just more simple things. Okay, so how do we use it? What we look for is the power that we're raising a binomial to, the third power. So I'm going to really quickly create a Pascal's over here, since I went past it. And what we do with this one, it is a third power. We're going to use the row that has a 3 in it, where the second number is a 3. Third power, the second number is a 3. And what we do is we steal these coefficients. 1, 3, 3, and 1. Okay, and then every time we take the first term and raise it to this power. And then for the next one, we go down 1. And then for the next one, we go down 1. Down 1. And for the next one, we go down 1. Okay, so we do that with the first term. And then we do the same thing with the second term. But we go in the opposite direction. We go 0, and then we go up 1. Then we go up 1. Then we go up 1. And then we do the sum of all of these products. Okay, this is where I'd like you to use your calculator, because I want you in your calculator to do 1 times 4 to the third. What is 1 times 4 to the third? 64. What happens when we raise anything to the 0 power? That is 1. So it's really like 1. Anything to the 0 power we can kind of cross out, because it's like multiplying by 1. Okay, now I want you to punch this into your calculator. 3 times 4 squared. What is 3 times 4 squared? 48. Now I want you to punch this. Actually, never mind. What is 3 times 4? 12. But this time it's m squared. And now this time we just have a 1, so it's m cubed. So 4 plus m to the third power is 64 plus 48m plus 12m squared plus m cubed. Okay, so we can. If we did, we would move it around.
But it doesn't have to.
It depends on your directions. It's not wrong if you don't, unless your directions say to.
Will your directions always say to? For regular math?
Not for expanding these. I'm not going to be particular about that. All right, so let's skip to number 3 because it's a different power. Okay, this is a 4th power, so I need to take my triangle and make one more row. 1, 4, 6, 4, 1. So that's where I start. 1, 4, 6, 4, 1. I'm just going to kind of cover up these other problems for right now. I take up a lot of space when I write up on the board. Okay, now we take the first one and we start it off to this power. And And then we go down 1. And then we go down 1. And then we go down 1. And then we get the 0. And the 0 is like it's not there. Then we take the second one. This time, guys, it's negative. So we do -3 to the 0. -3 to the first. We work our way back up. -3 squared. -3 cubed. And -3 to the 4th power. Now we are adding. There's addition between each one of these. Okay, now I see another 0 power, so I'm just going to kind of scratch that out because anything to the 0 is like 1. So what I have to punch in my calculator here is 1 times 2 to the 4th. What is 1 times 2 to the 4th? 16. Now, do you see that that x is also being raised to the 4th? So this first term becomes 16x to the 4th. Now let's do my next one. So what I have to punch in right here is a 4, a 2 to the 3rd, and a -3 to the 1st. 4 times 2 to the 3rd, I guess I can do that like that, times -3 to the 1st. All right, punch that in your calculators. -96. Now, this variable x is also raised to the 3rd power, so it's -96 x to the 3rd. All right, now let's do the next one. Let's see what kind of calculations we have this time. We have a 6, we have a 2 squared, and a -3 squared. So punch this in. 6 times 2 squared times -3 squared. Now, when you're raising a negative number to a power, make sure you put it in parentheses.
I got 216, but I'm not using it. I don't know what to do with it.
It's positive. That's pretty cool that you can do that in your head. It is positive 216. And then x is being squared. All right, let's do the next one. What we'll punch in is 4, 2 to the 1st, -3 cubed. Okay, guys, starting next week, you have to have your graphing calculators every day for math class. So if your plan was to check one out from school and you have not done so, you need to make sure you get that calculator contract and turn it into your math teacher. Okay? Your math teacher is the one that will assign you the calculator, but next week everybody has to have a graphing calculator. Does anybody need a calculator contract? You are new to our school. Did you need one or do you have a graphing? You're good. Okay. Make sure you get these signed and turned into your math teacher. Okay.
I got 72 something there, may not be right.
I got negative Negative 3 cubed is negative 27. So if we
Oh,
double that, it's negative 54. And if we multiply that times 4, it's negative 216.
Squared instead of cubed.
Gotcha. So this is negative 216x. And then the last calculation we're going to have to do on our calculators is 1 times negative 3 to the 4th. 1 times negative 3 to the 4th is positive 81. All right, do you guys have questions about that? Yes, sir.
Is there an easier way to do it?
This is the easy way to do it. Believe it or not.
What's the harder way to do it?
Okay, I'll show you the harder way.
No, please do not.
Yes.
2x minus 3 to the 4th is 2x minus 3
Oh, yeah.
times 2x minus 3 times 2x minus 3 times 2x minus 3. So we have to distribute it.
3. Oh, no.
Those two.
You have to do that with every single one?
Okay? And then we could take this one now and distribute through, and then take this one and distribute through, or I could multiply those two next. I'll do that. And since these two are just like those two, I know I'm going to get the same thing. Okay, now I'm not done. Now I have to distribute this all the way through, and then this all the way through, and then this all the way through. And then I have to add like terms. So to distribute this all the way through, I would get 4 times 4 is 16x to the 4th, minus 48x cubed, plus 36x squared. Next one, I chose green. Okay, 12 times all that stuff. Minus 48x cubed, plus 144x squared, and then 12 times 9 is minus 108x. Now, this all the way through. So, I really should keep going. So, I get plus 36x squared, minus 108x, plus 81. Now, I have to add like terms. I can't even see it all. Okay, so I come back over here. This is my only x to the 4th, so I'm good. Then here's a cube, here's a cube. Let's make sure there are no more cubes. No more cubes. Okay, so there's my 2 cubes. 96x cubed. And then a squared, a squared. Let's see if there's any more squares. Oh, another square. All right, so 36 and 36 is 72. And 72 and 144 is 216. All right, now x's. All right, so I got a negative 108 and negative 108 is negative 216. And then I have 81. Now, there it is. So that's a long way. So that's how much work we had for that problem that way. And then this had 2 lines of work. So it is kind of a shortcut, but it's not an easy shortcut. I'll give you that. It's not an easy shortcut. Okay, so tonight your homework is in your regular class. You don't have homework for me.
Oh.
You have homework in your regular class. And instead of doing more extra examples right now, I'm going to pull up your homework from your regular class, and I want you to start working on these. Are you kidding me?
Wait, we had homework for regular class?
Yes.
Oh.
I'm hating technology right
I
now.
have a picture.
I have them somewhere too. I printed them yesterday. Yeah, everybody has homework.
Wait, did you tell the class that we had?
I did. I can open up the last page of our notes and it says it.
I probably like dozed off a little.
Maybe you did. Alright, so here's your problems. Number 1 is x minus 4 to the 4th.
Oh my gosh.
Number 2 is x plus 2y to the 3rd. Number 3 is 8 minus x to the 3rd. Number 4 is 3x plus 4 to the 5th. And number 5 is x minus. I feel like you're packing up. I feel like I'm going to get a lot of detention. We still have 4 minutes. We're not wasting 4 minutes. Keep going. This is your homework in your regular class. I want you to get started on it. Okay, you start with the biggest number on the first one, and you work your way down.
I can't do this. There's too many. It literally takes up the entire page. And I'm like,
Yep, 3, 2, 1.
This will be.
yeah, it's like me.
Okay, so the first one starts with the highest, and you work your way down. The second one starts at 0. So the second one starts at 0, and then you work your way up. 0, 1, 2, 3.
If someone she opens my
Can we plug it in our calculator?
Yeah, we're doing it.
I got
Say, this one?
Yeah, so you don't do the variables. You just do the numbers. 3. So this was 2, 4, and 2 to the 3rd. Just the Okay, guys, when you punch it into your calculator, you're only punching in the numbers. Okay? So, the 4th row is 1, 4, 6, 4, 1. Let's talk about how you start one more time. To start, we start with the first one to this power, and then go down 1. Then go down 1. Then go down 1. Then it goes away because it's to the 0. Then you do the second one, starts at 0, and works its way up. You don't combine anything this way. You're just, when you multiply, you're done. So you'll multiply 1 times -4 to the 0. 4 times -4 to the first. 6 times -4 squared. The variables, you don't punch in your calculator, you just write it down.
Try it again.
Oh, yeah, sure.
That's so mean. I'm sorry.
Why do you like always follow me?
Well,
stay in class right now, not follow you.
Yeah, I know, but if you ever live with me, you're just gonna be like, hey, did you eat? No. You won't make me, I'll just tell you.
Well, I make food almost